Well, hello guys, yeah, I'm back. Got her pretty much done. There's a few little minor touches here and there, but I was going to try to do a lot of the work on camera, and I tried that for the last 2 days, or a day and a half anyway, and I just had all kinds of problems. Every time I'd go back after I made a video and look at it, it looked either I had my head in the way, my hands in the way, and then half the time I was sitting there trying to worry about whether I had anything in the way and not paying attention to what I was doing and making mistakes and stuff. So until I come up with something better, we'll probably just do a little work and then show it, do a little work, show it, and explain what's going on. Anyway, it's working. It'll probably do better once it's in a case, because there's a little bit of things that the case would shield it. So anyway, that's one band. There's the next band, and so yeah, that's the highest band. Now we go down the lowest band. It's got a little dirtiness in it, which I found out was part of it is the I don't know, it deals with the attenuation switch and the potentiometer that I'm using and stuff, because if I connect the scope up above before it goes through any of that stuff, it's a lot cleaner signal. So when it's going through the attenuation switch where you can change your levels, and then the potentiometer that does the fine-tuning of that, it seems to dirty it up a little bit. It could even be the coax I'm using, I'm not sure, although it shouldn't be, but it could be. But anyway, we've got her pretty well together, and now we'll kind of talk about what's going on here. It modulates just fine, and so there's the modulation going on in it, and we can adjust its level. I don't know if I can get that to behave itself. Nope. But so it seems to be doing pretty good, although the voltage is a little bit low on the plate. So probably what I'll end up doing, shut this off, is this resistor here, it's 22K, so I might lower it down to increase the voltages, take it down, play around with it, maybe around, say, oh, I don't know, 15, 18K or somewhere in there. Probably start out around about 18 and see where I'm at. But the voltages are a little lower than I like to see on the plate, so about 25-30 volts low. So I'll probably play around with that a little bit, and I might even play around with seeing if I can help this with doing some shielding around the attenuation switch, see if that'll help a little bit with the waveform. But otherwise it's working just fine, and it really looks about as good as any other. Now I don't match up to the scale. Lowest frequency is somewhere around 2 megahertz, a little under on the low band. There's 3 bands to it, and that'll range up to around almost 7 megahertz, and then the I didn't check the medium frequency band exactly. The highest frequency it'll go on the high band is around 60 megahertz. So not too bad a range for the most part. Now it's not, you know, it's not going low enough to, and I knew it wouldn't because the coils I used, you'd have to use a lot more windings on that low band coil to get her to go down into the area of around, you know, like 455 or 400 kilohertz. But the principle is the same. You just adjust your values. Now I want to kind of go over a little bit what kind of oscillator it is. This happens to be a Colpitts oscillator. Let me flip the thing back over and we'll kind of compare between what's going on here. And okay, in a Hartley oscillator, you'll have a center tap winding that'll tap off usually at more at one end, not really dead center, and you'll split that winding up between the plate and cathode and the grid, and you'll use, if you use tuning, you'd use only one single condenser. In a Colpitts, it's just reverse. We use a split condenser. You know, it's going to ground. Ground takes it to cathode. It's the cathode return, and because cathode goes to ground, and then one side will go to the grid and the other side will go back to the plate. Now in this one here we got 3 coils that'll hook in series, so that when turning the switch will actually take out or add in coils to increase or decrease frequency, as in here. So that's why you got more coils, but the basic circuit is like this. And the way it works is when it first comes on, the plate starts conducting, the tube starts conducting, the plate starts flowing current. That starts charging up this capacitor. Well, since it's connected to this one, you'll get a conduction through and start charging this capacitor. It's when they get so up to a certain charge, at a certain point, they start bleeding back, and we start getting voltage going through the inductor. And as this goes on, at some point here, this charge will get so high that it actually shuts off the grid, or shuts the tube down. Takes it into cutoff, and the tube shuts down. Then the capacitors start discharging fully through the your inductor or coil. When they get to a certain level, as the capacitors discharge, at that point this is going positive. As it goes positive, it comes out of cutoff for a short duration of time and sends another pulse down to recharge the first capacitor, which in turn will charge the next one, the second one. And this will just keep oscillating back and forth as we discharge the caps and charge up the coil, and the coil then gets fully charged, and then it starts discharging through the caps. In the meantime, what happens here is when the signal gets to a positive peak, the tube can conduct. Oscillators are generally Class C operation, meaning that the grid is biased extremely negative well into the cutoff range, so that you only get at the very high positive peak of this oscillation here will you get the tube to actually conduct, and then it'll, for a short period of time, it conducts and charges the capacitor, and to keep the oscillator from going. Now the difference between this one and this one is just the fact that we made taps off of off each one of these, 2 taps off the coil here, and what that does is split the coil up into smaller chunks, which reduces the size of the coil, the inductance, which increases the frequency. So that's all you do when with one of these, is you just tie your coils in series and then just tap off at those different connections, and then that when you turn your band switch, you're flipping in either just one coil, two coils, or all three coils. All three, lowest frequency. Just two of them, your medium frequency. Just one, your highest frequency. Or if you got 4 or 5 or 6 coils, however many coils you got. Now the rest of the circuit, basically, this is your oscillator right here. The other half of the tube of the 12AT7 is a cathode follower buffer. It's an amplifier that amplifies the signal that's coming out of the oscillator, and what it does is, by amplifying it, also isolates it, so that the oscillator does not get too badly loaded from sending a signal out, and whatever is connected up, wherever you connect the signal generator to, could load the circuit down. By use of a buffer, then that'll amplify the signal, only amplify it, but it also isolates the oscillator from that load. So, and generally you use a cathode follower because it does a better job at actually isolation as far as the oscillators goes. When I get more deeper in tube theory, I'll explain how a cathode follower works and the differences between it. But anyway, that feeds out from there, and you got your fine attenuation, your coarse attenuation, which is just a series of resistors, a voltage divider circuit, and that will determine how much is getting through, and then that feeds on out to the jack. The modulator, it feeds down through, comes through a control, through a switch, and feeds into the grid of the cathode follower. So this is not only acting as a buffer, but as a mixer also, or a modulator, and then that signal feeds out. So now that's about all I've got on this. I'll go over it a little more in another video as I get things kind of finished up, and I'll create a parts list. I had to do some changes. I made a couple, 3 mistakes on the original schematic when I drew it out. Somehow when I went from my rough draft to something that was a little more presentable. So I'll get that uploaded with a basic parts list and stuff, so you kind of got an idea. The transformer I used in here is just one I had. It's really a little bit more beefier than it needs to be, but you know, that's fine too. Now I want to talk about some future videos. Again, there'll be another video on this, to just a little more in-depth explanation of what's going on here and stuff, and just talking about the different parts I got and what could be substituted and so forth, and some other things. I have decided that I'm not sure when I'll start it, but I want to, in between doing just videos like continuing with the builds, I've already kind of started on the signal tracer right here. So I mean, it's just basically a little bit of wired up, but nothing really to talk home about yet. But in between doing those and, you know, videos of working on radios and stuff of that nature, I want to do 3 types of videos. 2 of them will be theory. One will be theory with not much math to it. If there's any math, it'll just be real simple, like Ohm's law or something. Another theory series that'll go in conjunction with it will be more geared with more math, with the idea that, you know, anybody that's actually wanting to do any type of design, or at least a deeper understanding of the figures and everything that goes into design. So we'll have a theory, a series of theory that's just kind of like I did today, just, you know, explain kind of basically how the circuit works and stuff. And then there'll be a theory series that would go into a lot deeper explanation. I'll have a lot more math to it. And then I want to do a math series, starting out with basics and working the way up. And mainly because of, I know a lot of people have troubles with math, and I want to do my best to help you with that, to get you past having troubles with it. Most people have troubles because, and I'm not trying to put down any teachers, but because the way school systems are set up, and when I talk schools, I'm not just talking about like high school or grade school or anything like that, but also colleges, universities. Teachers are limited to a certain curriculum. They've got so much they got to teach to you and to the class, and they only have a specific amount of time to do that in. So they're limited in how much they can explain any one particular subject. So I'm not, you know, and that does cause problems with a lot of people. You know, you get behind just one thing, one little thing, one minor little thing, say early on even, and that you can't grasp, you're having a hard time grasping. That'll throw you off throughout the entire rest of the period of time in school, because math does build upon itself. So I thought I'd do a series on math also, and it'll be math, not as pure math that's geared towards tube electronics, but it's still going to be more math and less theory and stuff. So anyway, be probably a week or two before I get started in that. I'll probably start the math before I start any of the theory. In the meantime, continuation of stuff like this, and the signal tracer, and so on, with complete schematics and parts lists that are fully finalized when everything is working, to be uploaded, so that, you know, if you want to build one, you can. And I'll try to work where I'm using very popular, easy to get tubes and parts. About the only thing will be just like transformers, but I'll work out some ratings on the transformer too. So anyway, until next time, thank you for your comments and for watching, and I've got some new subscribers too, a couple of them, and I thank you. So just stay tuned, and I'm hoping to have something for everybody, you know. So anyway, until next time, goodbye.